Hi, my name is Tiana Liu, and I'm here to do the probability homework 5 problem 1. For this problem, we already have the fx and fy, and have the relationship between x, y, and z. So we need to have find the fz. So for the first one, we need to do it in the convolution method. Of course, it is complicated in the process, so I rewrote it, some part of it. So first one, we have the fz. We're using by the fx alpha and the fyz minus alpha given by the problem. And we can see the step of this one. It is to write out the fx and fy. But since fx is using a little bit right shift by 1, so we will use the original one and the right shift as the last step. So for this one, we separate it out one by one to find each of the integral. Then for this step, we bring the z into the integral range, and to simplify the integral process. And for the next step, we just simplify the integral the outcome to this formula. To roll it, we should have this one. Here's the outcome of the formula that we have for the convolution method without the right shift. Obviously, for the problem, we already have the fx to the right shift one. So for this one, we also need to right shift the z during the process. So it will turns out to be. Yes, after right shift, I think the problem should be like this. Here's the outcome if we do it in the convolution method. And for the next, we need to do it in the geometric method. Based on the clue, we have it to separate into 3 parts. First one is z less than or equal to 1, which means that the cover of the shaded area is not over the uh, entire square if we're using the picture of the clue. So for this one, we can have the fj goes to probability of z is in z, which is means. And for this fj, we can do the integral. We can do the derivative to get the probability of z, which is equals to z. Because this one to this one is a derivative process. And then we need to calculate the second part, which is there's some part of the triangle that over the square, but some part of the triangle is inside the square. So which is they larger than 1, but that's all equal to 2. So we have the f they goes to probability z. Same process, but for now we have the total area of the triangle is z square of 2, but we need to minus 2 parts of z minus 1 squared over 2, which will be z minus 1 squared. To split out, it will come like this. And do the derivative of this formula, we will have the probability of this one turns out into minus a plus 2. So this is the formula for this range for the range of the z from 1 to 2. And last one is z over 2. Obviously, the counterpart is the only counterpart is the square that is consistent. So it will comes like 1. And to derivative it, we will have fz, probability of z equals to 0, right? So here we get the 3 parts of it. Then we have the formula of the fx and fy. We bring it back into this formula. We will get the same formula as a convolution problem have. Convolution method have, which is this one. So for this problem, if you're doing a geometric way, the most important thing is to focus on the area and the graph instead of just looking at the formula, which is different from the convolution problem, convolution method. So here's the answer of the problem 1 for the homework 5. Thank you.